All right, good morning, folks. Just our next video is on implicit differentiation, and as I mentioned in our lesson notes, differentiation is a way that we can differentiate expressions that contain a combination of x and y variables. So we've already seen some examples of this in terms of circles, ellipses, hyperbolas. They're not as simple as just having y equals something with an x in it. So we can mess around rearranging the equations to get y by itself, but that's not always possible. So a way we can manage this is to use what's called implicit differentiation, which essentially just applies the chain rule to help us differentiate any part that's got y in it. Now, the first thing we have to remember as well is that when I am working with these expressions, essentially they are an equation, because I've got this equal sign in here, and we have to remember the number one rule with any equation, and that is what I do to the left hand side I have to do to the right hand side to keep it balanced. So I'm going to start differentiating this, and essentially using that equation rule I'm going to differentiate the left hand side with respect to x, and I'm going to differentiate the right hand side with respect to x. I did that back to front, but you get the idea. So I'm going to differentiate this side with respect to x, and I'm going to differentiate this side with respect to x. What that looks like is this. So I'm going to differentiate the x in terms of x minus, I'm going to differentiate the square root of y with respect to x, and I'm going to differentiate the 2 with respect to x. Now this all works well for parts of the expression, but not all of it. If I had the term 2 and I differentiated it with respect to x, it would just get an answer of 0. And if I differentiate the term x with respect to x, I get the answer of 1. So that's really easy. But what happens when I differentiate the square root of y with respect to x? Can I differentiate y with respect to x? Now I can't just make this equal 0 as well, because y is not a constant, y is a variable. So what I do instead, I can't differentiate with respect to x, so I'm going to differentiate the square root of y with respect to y. How can I do that? Well, it kind of doesn't work initially because I've got this dx in here. And I want to find out what dy dx is. I don't want to find out what sum of dy dx is and sum of it dx dy. So what I apply is I apply the chain rule. Now if I multiply this by dy dx, then my two dy's would cancel out, and I'm still differentiating in terms of dx. So what that means in essence is that basically whenever I differentiate a term with a y in it, simply multiply by dy dx in the expression. Okay, so come back here. The first part, as I said, this differentiates to equal 1. The second part, I'm going to differentiate the square root of y. So I'm differentiating the square root of y with respect to y. And the easiest way to do that is to rewrite it as y to the power of a half. And when I differentiate that with respect to y, I get a half y to the power of minus a half, or 1 over 2 root y. This is a pretty handy shortcut to remember. If you remember, if I differentiate anything with the square root, it becomes that expression. Then you can sort of like save some time doing this step, and it pops up a little bit in specialist exams. So handy shortcut to be able to jump that step. Alright, so when I differentiate the square root of y, I get 1 over 2 root y, and I still have to keep in my dy dx here. Alright, so I've differentiated everything now with respect to x, but what I haven't found is what dy dx is actually equal to. So to do this, all I'm going to do is rearrange my equation, and I'm going to move that whole section here to the right hand side, which gives me 1 over 2 root y dy dx. And then this is just my algebra skills. I have to try and simplify this. So I'm going to multiply both the left-hand side and the right-hand side by 2 root y. And that gives me 2 root y equals dy dx. And that's the answer to my first example. The second example we had in today's lesson was to find dy dx for this expression. So we had 4x plus y squared minus 2y minus 2 equal to 0. Now I'm going to try and take a few shortcuts this time. So without explaining all of it, I'm just going to remember the idea of with equations, what I do to one side I have to do to the other. So I'm going to differentiate the left-hand side and I'm going to differentiate the right-hand side. And then I'm going to remember when I differentiate anything with a y in it, differentiate with respect to y and multiply it by dy dx, effectively applying the chain rule. So that will look like this. If I differentiate the 4x, that would give me 4. If I differentiate y squared, well, if I differentiate with respect to y, I get 2y. And because this is a y term, I multiply it by dy dx. If I differentiate negative 2y, it equals negative 2. And because it's a y term, I multiply it by dy dx. And if I differentiate negative 2, I get 0. And also don't forget to differentiate the right hand side of the expression. If I differentiate 0, I also get 0. Alright, so now I've got this equation and I have parts that have got dy dx's in them and parts that are just numbers. So let's try and put this together a little bit. The first thing I'm going to do is I'm going to just sort of like cross out this 0 because I don't really need to have a minus 0 on the end of it, and that drives me a little bit nuts. And then I can see I've got my first term here, just a 4, really simple. And then I also have a term with dy dx. There's one term with dy dx and a second term with dy dx. Now I'm trying to work out what dy dx is. So if I'm going to work out what dy dx is, I don't want to have 2 dy dx's in my equation. I want to have just one of them. So the first thing I'm going to do here is I'm going to move the 4 to the other side of the equal sign and rewrite my expression as 2 times dy dx, and I'm going to use the dot multiple here for the simple fact that I can't mix it up with any x's. And then 2 times dy dx equals negative 4. Alright, I still have 2 dy dx's. So the really simple way to manage that is I just take out a common factor of dy dx. Still being times by in here, and I would end up with 2y minus 2 equals negative 4. So finally, if I want to find out what dy dx is, I have to divide both sides by 2y minus 2. And my final expression becomes dy dx equals negative 4 over 2y minus 2. And there's my expression differentiated. So relatively simple once we start using that shortcut and don't overcomplicate it for ourselves. Alright, the third example will get a little bit more complicated, and I'll explain why in just a moment. But our third example is y equals x squared e to the y. Alright, so what we also have to remember, yes, I am going to differentiate the left-hand side and the right-hand side. I'm going to remember that when I differentiate anything with a y in it, it becomes, I differentiate with respect to y and then multiply by dy dx, effectively applying the chain rule. But what I also need to remember is in between these two parts here is a little sneaky time sign that I don't write in there. So this is actually a product rule problem because I am differentiating two functions that are being multiplied together. So let's have a little bit more of a look at that. We need to differentiate y with respect to x. Now don't confuse that with dy dx because it's not the derivative, it's not the rate of change yet, it is the variable y differentiated with respect to x. So putting in the brackets might help you. And then I need to differentiate x squared e to the y with respect to x. Alright, this is a classic kind of problem where people would forget to differentiate the y. So let's work with the left-hand side first. That's relatively simple. If I differentiate y with respect to y, differentiate y, you get 1. And because it was a y term, I multiply it by dy dx. Now notice no bracket around the y anymore. Okay, so I've actually differentiated the left-hand side. Now let's have a little think about this x squared times e to the y. Now I'll do this formally with the product rule so that you can see how it works. So if I let u equal x squared, when I differentiate u with respect to x, I get 2x. And then if I let v equal e to the y, when I differentiate v with respect to x, okay, when I differentiate it in terms of y, so e to the y, differentiate e to the y, I get e to the y. That's our rule with exponentials and the natural number e. But I differentiate it in terms of y here, so I've got to multiply that by dy dx. And then when I put that together with the product rule, I keep the first one. So I'm going to put the u with the dv dx and the v with the du dx. So I'm going to keep the first one, x squared, and multiply it by the derivative of the second one, which is e to the y multiplied by dy dx, plus I'm going to keep the second one, e to the y, and then multiply it by the derivative of the first one, which is 2x. A little bit of tidying up. We don't need all those time signs. I can just write it as x squared e to the y dy dx plus e to the y 2x. And I could take out common factors, but I'm going to leave that for a little bit to see what happens, because remember, I want to try and find out what dy dx is here. So my common factor probably needs to be dy dx before anything else. So x squared e to the y dy dx plus e to the y times 2x. So I'm going to put the 2 in the front and the x at the end. There's my expression. Now I want to find out what dy dx is, so I have to get my dy dx parts together. So I'm going to start on the left-hand side here. I already had a dy dx, and I'm going to subtract x squared e to the y dy dx. So I bring both my dy dx's to the left-hand side, and on the right-hand side I've got 2 e to the y x. So we've really got to get our algebra skills cranking here. We've got to be onto it, and you've got to keep careful note of what everything is. And that only comes with practice. So dy dx, I'm going to take out as a common factor, and I end up with 1 minus x squared e to the y. And that's, I'm going to actually put the x in front of the e to the y there, because I think that looks a little bit neater. Not required, but I just like it better. Now, final step, I'm trying to find dy dx, so I have to get rid of this multiply by 1 minus x squared e to the y. So dy dx would become 2x e to the y divided by 1 minus x squared e to the y. And there's my final expression for the derivative. Okay, they're my 3 examples for today. Key summary points. Don't forget to differentiate all terms, both left-hand side and the right-hand side. Whenever you differentiate a part with a y in it, just differentiate with respect to y and then multiply it by dy dx. To get dy dx by itself at the end, get all of your dy dx terms to the same side of the equal sign and factorise.